So, Alexandros, did you have a presentation?
Yes, let's see if we can share now. Do you see my presentation?
Yep.
Good. And let me press the play button. There we are. So this is a great pleasure to be here talking about satellite and with people that work with satellites. So this is joint work, as you can see here, with Ola Hall and John Östh. And this is very recent data, so it's work in progress, actually. Predicting human development from satellite imagery. And here, as you can see, I have added in high definition. so you'll see why this is. We're using a machine learning approach, of course, using remote sensing data and multimodal data over Sweden for this study. What specifically is human development is the following, is the Human Development Index we're talking about. And that combines, for those of you that are not aware of, combines 3 dimensions in it: the life expectancy, which is health and longevity, education index, which is years of schooling, and income index, gross national income per capita. And this is combined into something that is between a range of 0 to 1, and that's called the HDI, or Human Development Index. And we will try to predict this from space. So our research question, as you probably can see here, is that can we actually use available satellite images to predict HDI, and then at what spatial range would that be possible? So that's the question. And without further ado, let me explain. I have rewritten the question, the research question at the top. What is the data and the method we're working on? The data set, as you can see here, is 700,071, huge number of grid cells of HDI. This is covering all of Sweden, and point out it's at the 100-meter resolution, is unfathomable resolution on this data set. And we combine this with 67 features derived from Sentinel-2 data per cell. And those include spectral images and indices. We categorize this into 3 temporal seasons throughout the year. And then we have seasonal coefficient of variation. We have nighttime lights and global human settlement. So this is our input data set. And our methods are simple at first. Actually, it's very powerful. The LightGBM is an extremely powerful method. It works miracles for this humongous data set. So I wouldn't say it's simple in that respect. And we couple these to Bayesian hyperparameter tuning, obviously, in order to get the best results. And on top of that, we're very, very strict here. We're going to do spatial block cross-validation, and the blocks will be further apart, so there will be no leakage. We're very careful about our machine learning method, so there is no leakage or anything like that. That's why we do it tenfold. And then we look at different scales, because remember, the question at the top is, at what spatial scale is that possible, if it is possible? So this is the method and the data. And the point is that scale matters here, and I'll give you some quick results. We are computing the national R-square, so we're explaining the variation of this prediction, not only at HDI, but individually at the educational, the income level, at every level. And I can show you here that 100 meters, the prediction is this, which is not significant R-square. So we're not doing very well at 100 meters at explaining the variation in the prediction, but at 1 kilometer, you see it starts going up, and then at 5 kilometers, we are doing even better in explaining. You know, we're going at education is 63 already, and at 10 kilometers, we discover the significant prediction that we can do very well in our predictions here. And here is a graph that visually explains the same thing. It's much easier to see the increase, right, in how well we're doing predicting this variation in the data. So this is important question, and this graph, this figure here, shows you that scale does matter, and at what range you see this prediction making sense. So the key finding, if you would, is that the aggregating satellite features from 100 to 10 kilometer increases this powerful prediction for HDI. And also, education is rather well predictable here at 0.711 at 10 kilometers. Life expectancy, on the other hand, is hardest, but still at 0.5, so it's not bad either. So the signal is there, that's the bottom line. It just needs this spatial context, as we are pointing out in this study. Also, we did one more thing. We looked at different, that was national data. Now we looked at specific regions like Stockholm versus Värmland, which is not heavily populated. And we did this same study at multiple scales, as you can see here in the image. And we are showing you R² again in this figure. And then we did calculate that R² is 0.703 at 10 kilometers. And then look at Värmland, which is not so heavily populated. Essentially, we get it stays mostly flat at all scales, right? Nothing there. And it may be not so strange, right? So the takeaway is that the satellite signal works well in dense urban areas, but not so in these lower densely areas, such as Värmland. So we have done similar studies elsewhere, but this is a nice representation here. And my last slide, because this is only a 7-minute presentation, visually, we can produce this amazingly high definition, high resolution, if you would, maps. And we can look in Greater Stockholm, we can look in Greater Göteborg or Malmö and other areas in specific detail and predict this Human Development Index from space. We thank you very much and welcome any questions.
Thank you so much. Yes, Thomas, if you have a quick question.
Yes, just a very brief question. This seems to follow some sort of rank size rule. Do you have access to longitudinal data if you can assume that it's scale dependent to an extent, to look at changes over time and where they might show up? Excellent
point. I didn't mention that this is specific year data. We didn't look at changes over time. So we only have a specific year and we only did that. So that would be the next step, changes. Detecting changes, absolutely.
Okay, Alex, you had a question as well.
I was curious if you're familiar with the mosaics approach to the global HDI evaluation, whether you evaluated that and how your approach differs, but maybe that's too long a question for this format. But I guess if you're familiar.
I'm not familiar with that, perhaps. No, not myself. I'm not familiar with that.
Yeah,
I'll
share a link to it in the chat. Thanks.
Thank you.
Thank you. Thank you.
Stefanos, and then after that, John, if you wanted to add something to this part of the presentation, and then we can move on to the next part.
Yes, thank you very much, Alexandros, for presenting this very interesting work. I have mostly, ideas, because I find the use of this data set, it's very rare in my field to have access to this data. So I was thinking on the when it comes to the input, the satellite data, there is recent developments, for example, satellite embeddings from Tessera or from Google Earth, Alpha Earth, which I think they can provide information that are very difficult to mine using, let's say, indices, and they include definitely all of these temporal interactions. So I would be very curious to see if you would use them, how far it would improve the accuracy. And the second part would be on this very interesting point you made between the divide between urban and rural areas. So could someone make the argument that what this model essentially does is capturing like built-up density? Have you looked into maybe the future importance, or if you would use the building density, if you have building footprints, would this be like the primary driver of this prediction? Because if it is, maybe you can go deeper into urban morphology. So like the different characterizing the building patterns themselves, so you can get intra-urban details and variation in this. Just the ideas, very nice work, but it's I'm always getting excited with these things.
Yeah. And you're absolutely right. This is great points. Tessera, we actually are working with Tessera. It's a foundational model, and we have been working and are currently working. In fact, we're bettering Tessera. We're creating our own foundational model. Tessera is not as good. That's why we're creating a specific tailor-made foundational model for Sweden. Tessera is global, and we hope we can take it further from there. And also, we are using the building, the density building, as part of the input data for this model, in fact. And you can go a lot further, as you said. There's so many ideas in terms of how much detail we can take out of this model. Yeah, absolutely.
We have a few questions that came in. I would like to ask if you can save the questions until the end, so we have time for all the presentations.
Yes.
Next up is Alvaro, I believe, on your work on registered data.
Okay. So I want to present something much less fancy, but it's our work with Ola and Marcus about sort of tracing local well-being through time and space. And sort of we move from an operationalization to a research agenda. And the paper partly uses registered data, but also other sources of administrative data. It's basically what we're trying to do is calculate a sort of well-being index for all 290 Swedish municipalities, and moving originally was sort of an HDI for each of the municipalities, but then we moved a little bit to more kind of capacious approaches that include other dimensions, and we ended up measuring sort of the 6 dimensions. We have the economic dimension, we have education, health, we have security, we have a civic engagement or community, and something and inclusion. And we base our work on sort of the work from Amartya Sen and Martha Nussbaum about sort of capabilities and the distinction between sort of capabilities, which is basically the idea that those are substantive freedoms to live, for humans to live sort of a dignified life, and the idea of functioning that basically these are sort of the things that are realized. Sort of capabilities in this framework are sort of unobservable, and it's just it's kind of an ideal, right? And we end up measuring well-being. We call it well-being, sort of also in line with what the literature is doing, but we could also think about sort of place-based kind of capability environments. And the question that we asked was basically how are well-being and its constituent capability dimensions distributed across the Swedish municipal system, and what place-based structural characteristics are associated with these differences. And also we try to see sort of the development of these things during the 2002 and 2020. This is more detail about sort of what things are included into each dimensions, but I'm going to skip it in sort of sake of time. Sort of we have a couple of findings. The first one is that we observe sort of that when we decompose this well-being into sort of different dimensions, it's not about sort of a simple urban advantage. Of course, urban areas lead in economic, health, and education, but then you have a more mixed picture when you include sort of things like safety, civic engagement, and inclusion, right? So that would be kind of a first finding. Then when we look at sort of development in time, we have kind of 3 different dynamics. The first is that we observe a rural catch-up. Sort of the rural municipalities start very, very far away, but by the end of the period, they have caught up with not with the metropolitan municipalities, but with the rest of the system. Yes, there is a little bit of a urban divergence. Sort of urban municipalities improve on average, but there's much more variability within those, and that kind of goes in line with this idea of sort of segregation and sort of particularly in metropolitan areas. And finally, we do observe sort of a industrial decline where former manufacturing towns experience sort of broad-based deterioration across sort of almost all the dimensions, not only sort of economic decline. Yeah, and also we can see at the end sort of we have the last year we have COVID effect, and we can see that there is a bit of the only group of municipalities that is kind of negatively affected, but very little, is sort of the large metropolitan municipalities. Yes, let me move to. So then we have another finding is that sort of the industrial structure is persistent and kind of multidimensional, and we observe a very persistent correlation between sort of the share of the knowledge economy and well-being, but also a very negative and persistent relationship between well-being and the share of employment in manufacture. Sort of which talks to sort of the structural transformation and how places with sort of the related to the old economy have been losing, but also in this sort of multidimensional way of looking at things. And we also see kind of the story about left behind places and out-migration and discontent, where we see sort of a very sort of an increasingly positive relationship between internal and excess migration and well-being, and an increasingly negative relationship with sort of the discontent, and the way that we operationalize that is through this sort of voting for the Sweden Democrats, as the literature in sort of the geographies of discontent usually does. And here we see also the sort of in the out-migration thing that there could be sort of this feedback loop that is also discussed in the literature, that where sort of these places that are originally sort of disadvantaged also lose people, and this kind of deepens the disadvantage, and that could be also sort of the relative sort of strengthening of the relationship that we observe. And we finally see that we conducted this sort of a hotspot analysis, and we see that sort of in general the geography of this sort of well-being or capability deprivation is being sort of changing. We sort of in the overall index, we used to have some cold spots in the north, but they tend to disappear, but the sort of the hotspots that are associated with the metropolitan areas are persistent. But in other dimensions, for example, in economic, we used to have a very large cold spot in the north of Sweden that has disappeared in time. And for example, in terms of inclusion, which mainly includes measures of equality, we used to have a large hotspot in the north of Sweden, but that also has kind of disappeared in time. I'm going to skip that. So basically, we have three conclusions. One is that the territorial inequality is multidimensional, and of course, we have these three main dimensions where sort of urban municipalities tend to lead, but that picture gets kind of complicated if you include different other dimensions. The industrial structure seems to be a key determinant, and there seems to be this relationship between capability deprivation and kind of left behind-ness and political discontent. And finally, we kind of proposed a research agenda that starts by trying to look post-2020 to see sort of if there are any long-term COVID consequences. Also try to understand sort of the mechanism, how does industrial change translate into capabilities, and disentangle the political discontent dimension. What matters, where's, and how. Maybe different dimensions, but differently in different places to drive discontent. Also sort of bring it down to the individual level, try to understand how place-based capability environments shape individual life trajectories, and that could be effectively be done with the registered data. Then maybe some comparative studies, and moving also from assessing how individual places score to how they could under or overperform given the sort of their structural preconditions. And finally, sort of analyzing if there are any trade-offs between these different dimensions and how they apply and where. And yeah, that's that.
Thank you so much, Alvaro. Do we have any quick question to Alvaro before we invite Florian? Yes, Thomas.
Yes, well, thank you. Just a brief question that struck me. Sort of, did you? I mean, my question is this: did you control for age structure? Because it seems like issues such as health and well-being, those kind of things, are clearly correlated with the age structure of the population, and I think that would be sort of make it easier to actually talk about the differences seen when controlling for the age structure of the population.
No, the age structure is not. I mean, it could be probably very related to the overall measure and to some of the dimensions, but it's not included in any of the dimensions for now.
Okay, yeah, thank you.
Could be relevant to. It wasn't really included in any of the kind of the similar indexes or the literature that was out when we started doing this. So yeah, but I agree with you that should be relevant.
Hans, you had a question.
Yes, unfortunately, I came into this seminar a couple of minutes late, so I need to ask a stupid question. Will there be a list of pertaining publications on which all the speakers' presentations are based, or do I have to go and dig for myself?
I think we definitely can provide something like that afterwards if you're interested.
Yeah, that would be very nice.
Yeah.
I think, at least. I don't know. Maybe I'm the only one.
Thank you. Josie.
Hi, it's Linda. But anyway, I have a question about the map where you have mapped the hotspots and cold spots. Have you checked or used functions where you also look for outliers? So if there are outliers that disturb your clusters in any way? Or how have you measured the hotspot and cold spots?
Yeah, no, not really. I didn't include that. I used to sort of the standard technique. I would have to go back to exactly check what are the parameters I used. But yeah, maybe I can check that and revise that in a way. And maybe you can help me.
We can look at it when we meet at some point.
Yeah.
Thank you.
Thank you so much, everyone. Now we have our final speaker, Florian. You can easily have 15 minutes now if you'd like to. And then in the end, we can have a open floor for questions and discussions on all speakers.
Thank you so much. I share my screen. Yes, so my name is Florian, and I'm representing Green Urban Sites. We are a startup here from Lund, and we want to bring satellite data to everyone. So, and we want to turn it into urban well-being. So why is that so important? Yeah, maybe if we give some background first about Green Urban Sites. So I have been a PhD, as Ola said, I graduated from Lund University 2016 as a PhD student, and time flies. It's almost 10 years ago now. And my focus was on ecosystem modeling at the Geo Center and remote sensing. And I had some courses with Ola as well. So, but I worked then in different areas in medtech, then at governmental institution, then in a big company. But then I wanted to come back to my to my to what's very close to me, and that's remote sensing. Then we started Green Urban Sites. We are a startup from Lund, and we had Ideon Science Park in the incubator. We're also part of ESA Big Sweden, which is a business incubator from ESA. We have some projects funded by Rymdstyrelsen, the Swedish Space Agency. And we are a company, so we want to serve customers. We work in projects, but also we want to serve customers. And we have customers all over Europe. Yes, so why it's so important about, why is it so important to look at urban areas? So because 75% of us live in urban areas. And as you know, cities are warming twice as fast as any other area. And that has some reasons. It's not only heat in cities. It's not only a function of temperature itself. It's also a function of land use. So that's quite important. And then heat waves, they will be more common, even in Sweden. They will start earlier, last longer, and will even start very late in the season. And heat stress has, of course, an impact on our health and mortality. And that's, of course, a society cost that we need to consider. And heat also has a cost on our productivity. So when I think there was a study by United Nations Health Organization that with every degree above 20 degrees, our productivity goes down with 3%. So that means in future, when it's getting hotter, so office buildings need to be cooled down much more. So that's quite an energy cost that we need to think about. And at the moment, energy is quite pricey. So how to solve that in a good way? So what we do then, we turn satellite data into practical actions. So we don't look at 10-kilometer resolution. We look at sub-meter resolution, actually. So we do a high-resolution mapping of urban heat, urban infrastructure. So we build digital twin of urban infrastructure. That means like trees, shrubs, or anything else. But also we try to objectify phenomena like heat. We build objects of heat and follow them over time with help of satellite imageries. And what we do then, we analyze this and we suggest and model actions for stakeholders, municipalities, or maybe even a real estate company. So what actions can they do to reduce heat? Exactly. And nowadays, everything is spread around. So we try to put everything in the same box. So it will be very easy, or it is easy for municipalities and stakeholders to decide what to do about it, to improve our urban well-being. So yeah, I have an example from Austria, Graz. I don't know if you have been there, but we have some research cooperation with the institute there, the Ioneum Research. And there together we looked at how did urban heat developed over time. So here we see the city based on a satellite imagery. See here, yes. And close to it, we have a mean land surface temperature measurement. And you see, I mean, it's kind of correlated. Okay, so but is heat static? Is it always like that? No, it's not. So we have then looked, we went back in time with satellite imagery. It's a fantastic data source. You can travel back in time and look at things, how they have developed. So here you can really see how heat, so it means if it's getting redder and browner, then it's high heat, land surface temperature we speak here. And the bluer, the cooler it is. So here you really can see over time how heat has increased in the city. And it's, of course, climate change is a factor, but it's not the only factor. It's the land use. So what we see in the last years here. So green infrastructure or like agriculture fields have been converted into housing. And that's really what you see here. And that's a problem for the well-being, of course. When the municipality don't consider how to adapt to climate change, then it becomes very pricey. Once you have sealed the surface, it's quite pricey to change it again, to like plant a tree and things like that, because in the city, green infrastructure competes with other infrastructure. You cannot plant a tree everywhere or do something else because there are pipelines beneath the surface. So it needs to be considered quite carefully. So yes, how to mitigate an urban heat and improve urban well-being? Yes, we think nature-based solution is one important instrument to do that. Green infrastructure. And we have found out in our studies, green is not green. It's unequal green. So just having kind of a grass area doesn't have the same impact compared to having a tree, providing shade and evaporation, creating a nice environment, but also benefiting with other ecosystem services like cooling temperature, improving air qualities. And many cities already have understood that. Singapore, Phoenix, and Paris, they really use greenery in order to shade and cool down the cities. And there, of course, there's legislation coming in, the European Restoration Law, that forces cities to have a certain amount of green infrastructure in the city. If they don't follow it, they need to do something about it. Yes. And now I would like to talk about the project that we do. It's called Climate Sites. It's funded by the Swedish Space Agency. Just today, we had a workshop together with some municipalities. There we really try to map heat and everything on a very local level. So we do like digital tree inventories, live vitality analysis of the urban area, just because when you plant a tree, you also need to take care of the tree in order that it can survive in the urban environment. We do urban heat mapping, plantable spots analysis, so where can you plant a tree and where does it have the highest impact? Because it's quite costly to plant a tree in a city center. And then, of course, we do scenario analysis. We try to help them, okay, what happens if you do plant this kind of tree or do a different action? How will that impact the quality of the place? Because the quality of the place impacts our urban well-being. And of course, if you have digitized everything, it's very easy to report. Yes, yeah, if you want to know more about us, of course, we're a company. So follow us on LinkedIn, take a screenshot of our QR code, follow us on LinkedIn, or if you have more questions, reach out to hello@greenurbansites.com or visit our homepage. Yes, thank you.
Thank you so much, Florian. Do we have any initial questions to Florian to get started? Yeah, we have Stefanos.
Yes, thank you very much, Florian. Very interesting presentation and great applications. I have a question. I have worked in some similar projects before, and when it comes to urban well-being and, let's say, human comfort or discomfort, the variable that is typically of interest is the air temperature, right? Like 2 meters above ground, the one that the humans are actually facing.
Yes.
Do you have some models, or have you worked into that on how you can translate a bit the land surface temperature into air temperature? Because they are definitely related, but not the same.
No, exactly.
Yeah,
exactly. Good question. But I think air temperature is the wrong. It's a good measure, but it's the wrong measure for comfort. It's much better to look at radiative temperature, which is kind of a function of LST, because that gives you the real picture how the comfort of this place is. And air temperature, as you say, it's measured at 2 meters above ground, and then it's kind of in a shadowed area, and it's not so dense. So it's very difficult to model, to upscale it over a city area. Of course, you can use digital elevation models and see how it spreads, but I think air temperature is not the best tool to do that. It's much easier and better to look at land surface temperature, the radiative forcing, I think, and that's most, or the reflection of it, so to say. It's more valuable, I think.
Right, thank you.
Because, sorry if I just continue on, because it's not only like the ground level, but in cities you also have houses. So the sun, the photons hit the house wall as well. It's emitted, taken up, and then emitted during night. So it's much better to look at LST. I think it's much reveals more this kind of discomfort thing. But of course, people, if you show LST, everyone thinks about air temperature. Then they get really, but we really try to emphasize it's not air temperature. It's kind of another measure of temperature.
Sai, did you want to follow up?
Yeah. My question is regarding this. When we check land surface temperature or urban heat island effects in general, they talk about the morning one and the evening ones. The morning, the generally cities get heated up, and evening they're supposed to release the heat, but due to all the concrete surfaces, they don't. So my question is basically because when I worked on LST, one of the questions I got repeated is like, at what time are you checking this LST? Does the satellite passes through this particular city I'm researching on in the morning or in the evening?
Exactly.
You said you're working with sub-meter resolution. I'm assuming you're not working with Sentinel-2 or no, but I just wanted to know, like, are you encountering these issues, or how are you dealing with this?
Yes, so the sensor, we look at, for example, Lund now, where we are, the sensor passes between 10 and 11 in the morning. So it's not a real representation of the heat. And of course, we are not writing research papers here. So we try to give municipalities indicators how they should act on urban heat. So I think it doesn't really matter it does matter, but I think now, where we are now, it matters to know where is the urban heat spot and how does it move over the season at 11 o'clock, so to say. So that's what we do. Exactly. And then but we have an algorithm where we downscale it to sub-meter resolution.
Okay.
So we look at the bigger picture, but then if there's a heat island, we try to zoom in and look at it, what's going on there.
Okay.
I think it's Thomas, and then after that, Ola.
Yes, well, thank you, and maybe I'm excused since this is a lunch seminar for posing what may seem as a weird question here. But I mean, if you live in a country such as Sweden, you're sort of longing for the heat season. So I'm asking or wondering about the opposite. Is there an effect of winter greenery on urban cold or something like that? Because
yes.
Just curious, and it might sort of affect wind strengths in cities or something like that. So
yes.
Just asking, is there such a research topic, or is it completely irrelevant?
No, it's not, because I mean, so trees, they have kind of a canopy, and the canopy roughness also depends how diverse the area is. So the branches of the tree break wind, and that has an impact on cooling of houses. If you have a lot of house with windows, glass windows, and you have trees in front of it, so during summer they shade, very nice, and during the winter actually they help to a certain extent to not cool down the building too much. If you know what I mean. I mean, if the airflow hits the glass directly, it can suck out a lot of energy from the house. But if it kind of breaks, the tree breaks down the airflow, then it's less energy that goes away. And another thing is, and of course now in Sweden we are longing for the summer, but from today, let's say 2050, sorry, and 2050, I think the weather will be different in Sweden. And if you want to install nature-based solutions like urban trees and trees take a lot of time to grow. So if you want to adapt cities to climate change, you better start now, because otherwise it will be very difficult to adapt with nature-based solutions. Otherwise, we have it like in, have you been to Dubai, where they have like those mechanical umbrellas coming in and out. So depends how we would like to have our cities in future. So we already now need to think in Skåne at least how we want to vision our cities in 25 years from now, because we have a similar climate like in Sofia in Bulgaria.
Thank you very much, Florian. Very nice presentation. And dear God, please let us not have mechanical umbrellas in Sweden. Let's plant trees. But I have two questions for you. What is the response when you're working together with the municipalities? What are they thinking? What will be in their kind of decision space to do? Is that tree planting, or is it larger conversions of land cover and land use? So that is one. The other question that I have is, I realize that now when we're entering a new era in many ways in remote sensing, before 5 years ago, companies were calling us here in Lund wanting to sell data, wanting to sell images, planet, all of them. They was all over us. Now everyone is going into their companies and they want to sell services. So it's becoming harder. When I suddenly want to have high resolution data, it becomes quite hard to buy it, because they are protecting their sensors and they're protecting their intelligence. Is this something that you encounter as trying to make business here? How is that ecosystem working? So there were two questions. Thank you.
Yes. What was? Please remind me the first one. What was the first one? Could you tell me the first questions?
Yeah, it was more the response of the people you're working with.
Yes. Yeah. I think most municipalities. So, I mean, converting land use on a bigger scale in the city is difficult. I mean, as we have seen, the hotspots are in the city center, where trees need to compete with other functions, so to say. So municipalities, they want to convert, increase the canopy cover in the cities, but they don't do it on a large scale. They take it project by project. For example, in Lund, they now converted this Vårtullsplatsen, which was a place with not many trees, but we helped the municipalities to make a plantable spots analysis. So where to plant the trees in the best way in order to increase shade. So cities do it project by project, so to say, at the moment. And when it comes to data, so we buy data. We don't buy data from Planet, we buy from Airbus. And Airbus is not the problem. Of course, if you want to do the high resolution, you need to do geotasking. And to get to the geotasking has become due to many crises ongoing at the same time. And it's very difficult to order a geotasking. I can only agree with that. So at the moment, we try to work a lot with auto imagery given from the municipality. So we combine auto imagery with sentinel data, but sometimes we also buy. But UC, for example, you can also buy. They have a 15 centimeter resolution, I think, or 30 centimeter resolution. I don't recall. But it's pricey, I think. It's very pricey. I mean, Planet, last time I spoke to them, I had to buy at least for the smallest package to buy was 5,000 euros. It would be half of Skåne, so to say. And in order to build a scalable tool, it's too expensive at the moment.
Yeah, if I just can follow up, I think this is a luring problem for us to actually get, because then you suddenly want to do something over time, then there's becoming something different. And I also have the experience of these companies replying, if this is the application, then we will not deliver data. But if that is the application, then we can deliver, because then there's an application that they have not invested in. So, but thank you very much for your answer.
They want to, I mean, they have problems with, that's a different discussion, but they have a problem with profitability. So they want to own the full vertical action. But there are marketplaces like Skyfi or Up42 or what's called. There you can buy and even do geotasking if you want to. But you have to queue. Military operations are prioritized. There was one more question, I think.
Yes, Hans, did you have a question?
I realize that I'm here in the role of the outsider because I have very little experience with climate applications of remote sensing and other things, but at least in my personal view, I still hope that climate change could be reversible. Because what you said before was like starting to plant special plants and others which normally are not grown in this area, but will be maybe grow in the future. But if we make a political effort that we can, for instance, convince the Americans to stop using all this bloody gas and all kinds of other things, do you see it impossible to keep a status quo?
That's a good question. I think that we need to more than 8 minutes left. But what I can say, when I was a PhD student 10 years ago, I was also hoping that we can stop climate change. But now I changed my mind. Climate change is there and it will just happen. So we need to adapt to it. So the best thing is to adapt on nature-based solutions. Climate change will happen. And of course, what you say now, Hans, but if you then want to adapt to climate change or mitigate climate change, I think that's the right word, then you need to plant the right species that will survive in cities in the next 50 years. Okay. Because most species that we have now, they won't.
Thank you for the answer, but I need to say that I am a sturdy optimist. So I hope that, like in my own opinion, other people will change their mind and help me and others to kind of mitigate the effects of climate change. And I think it's very good that you work in all these things. And I regret I haven't done my PhD 10 years ago. Unfortunately, it was much longer, and I have worked in other areas. And I think that whatever we have achieved with remote sensing during the last 5 decades is quite fantastic. And I hope you'll all go on, and I'll try to do mine. Thank you.
Very nice. Thank you, everyone. We had one question that came in before this session via email, and it's directed to, I think, everyone who presented. And it's I posted it in the chat, and it says, can we see local well-being in Sweden from space? So that's the big question. And if we can use this data as ground truth and train on that, and if there's any possibilities or potentials in that. Thank you. I think it's maybe to Alexandros. So we had a few questions on that in the beginning as well.
I can quickly say one thing, that based on some of the data we have had, that's exactly the question we're trying to address. And the answer seems to be positive for areas that is well populated, because the signal is very strong there. We can actually say a lot and not, and is neutral. We can't give a definitive answer for areas that are less populated, because there is very few people living there. In fact, in Sweden, nobody lives there, as we have seen. So that's what we are seeing so far. But this is, as we're also saying, a work in progress.
Okay.
And then I add, if I may, Tilly, also I'm sending in, we actually yesterday got approved for a special issue where we are asking that very same kind of a question, advancing fine-grained and open data for urban well-being indices. I've placed the link in the chat. So if any of you come up with a solution, or if you have students to do so, that will be very, very beneficial, I think. It is a Spring in Nature journal, and it's free of publication up until the end of this year. So if you have any colleagues or friends that you know are living in countries where we haven't got the same opportunities as we do have in the Nordic countries, please suggest to them to send to this collection, and we will try to make sure that we give them the opportunity to publish on well-being and other things. Cheers.
Okay, amazing. Thank you. I wanted to just have a final summary of our session now. Can you see the slide?
Mhm.
Yeah. So thank you all for joining us today, and big thank you to all of your speakers for sharing your insights and your perspectives. And we hope this session has given you new ideas about how Earth observation and social science can come together in different ways. And I also, just before we wrap up, I'd like to highlight some of the upcoming activities that we will have here at SESAC. We'll soon gonna launch a survey to sort of help collaboratively shape the future of our activities. And we really encourage you to take part and share your input. We're gonna post this in our website and LinkedIn and other channels. And our third open session will be on the end of May, and that will be the last open session before summer break. And on that, we will have the theme of regional development. And then we will have some expert guests that we have invited. We're also gonna have, in the future of this year and going forward, we're gonna work on this Global Horizon Scan, where we want to explore the future of Earth observation and the social sciences broadly. And we are gonna release some news about that during the summer. And also then in the fall, we are right now in the middle of planning different things. We're talking about a bunch of beginning EO courses, and we're also gonna host a hackathon event where we will invite different stakeholders and different groups to come together and learn EO and craft some usable tools from that. And then we will also work on a fall open session series as well on different themes. So yeah, we hope to see you here at SESAC at our events. And I would like to wish you all a great rest of your day.